Hello, good morning, everyone, and good night from Santiago, Chile. My name is Eduardo Castillo. I'm a construction engineer based here in Santiago. I've been working within the construction industry for the last 11 years. I had the opportunity to do the UCL Master's program, where my dissertation was the paper I am presenting to you today. It is called Blockchain in the Construction Industry, developing a conceptual model for a resource sharing decentralized application. So the presentation outline for today, I try to grab everything in these 6 points. First, we have the context and problem statement. Then we have the research methodology. Then we will delve into the conceptual model. Then a quick review to the prototype and the feedback I gathered, the discussion, and finally some recommendation as a way to show some conclusion of the study. So this research addresses the construction industry operational and structural challenges characterized by inefficient payment processes, poor transaction management transparency, and inadequate stakeholder collaboration, worsened by hesitance toward digital technology adoption, as we all know. So the goal is to develop and evaluate a blockchain-based decentralized application framework to improve resource sharing in the construction sector, leveraging feedback from industry experts to guide future research and development. With regard to the research methodology, the study follows a strategic 5-stage methodology. First, we began by identifying key inefficiencies in the construction sector that could benefit from blockchain technology. Then number two, thorough literature review helped us understand the current landscape and identify gaps in the use of blockchain in construction. Third, using our insights, we crafted a decentralized application to address these shortcomings. And then in the fourth step, we engage with industry practitioners, conducting interviews to refine our DAP based on their expert feedback. And lastly, we discussed our results extensively, offering recommendations for DAP improvements and future research. This approach grounded our work in practicality and ensured it evolved progressively, leading to a well solution. So now let's move on to the conceptual model. First, this is the framework's diagram. It is a 4 concentric circle whose core represents the blockchain network, and the outer circle is the user interaction. First, regarding the blockchain network, we conduct research on the subject, taking into account previous studies, particularly a decision flow model for blockchain technology. We conclude that for the ultimate purpose of the application, private networks are the best option to ensure transaction security and user privacy. Among the different available options, then Hyperledger Fabric stood out due to its DAP readiness, modular design, and strong accountability, which are crucial for building trust among the construction actors. Then the next part of the circle is the DAP system architecture, which of course follows the Hyperledger Fabric workflow. Unfortunately, due to time, I can't delve more into this, but in summary, transactions of the application are validated by an endorser, and then batched into blocks by the ordering service. These are concepts that are well defined in the paper, of course. On the other hand, we had channels acting as a kind of private pathways that ensure transactions are confidential and efficient. This setup allows for parallel exchange within the DAP, without any interference. And finally, transactions are validated and logged by network peers. These privacy channels strengthen the process, upholding the integrity of the data, which support secure, simultaneous transactions without any disruption. Now, let's unpack the dApp's architecture key elements. First, we have the data privacy. Hyperledger Fabric serves as the guardian of transactions, securing them in its own private data collections, private rooms. These are kind of private rooms for data, ensuring its confidentiality. Next, we have got the authentications and digital identities, fortified by a robust framework within the Hyperledger Fabric, of course. Digital IDs boosted by S5-5 certificates and the MSP, Membership Service Provider, authentication that ensure every transaction is legit. Then we have the storage, integrity, and transaction of data. Hyperledger Fabric's ledger is smartly divided between world state and blockchain. World state for real-time data, and blockchain for the full unchangeable, of course, transaction history. It's private, it's traceable, and solid. Then we have the wallet security. In the realm of the wallet security, our architecture is triple layered, managing keys, orchestrating in transactions, and providing transparent yet secure operational environment. And finally, here we have the last key element, the smart contract or chain code, as they are called in the Hyperledger environment. This is built on the principles from Das et al. 2022 study. Chain codes are organized into functional layers, facilitating the development of smart contracts and enhancing the robust security architecture of our blockchain. So here then, regarding the prototype and feedback phase, the prototype development was made without any coding involved. It was made by designing a dApp mockup on the proto.io platform. The potential users were selected from industry, of course, being them industry practitioners with between 10 and 15 years of experience. And through semi-structured interviews, data was gathered, and the whole feedback was grouped into 5 categories, which were used for discussion later. These are problem validation, dApp evaluation, concerns, challenges, and improvement suggestions. Here you can see, you can have a quick view of the dApp mockup. It basically shows the user interface with a standard flow for a normal purchase. Now let's dive into the discussion, which was done from the feedback from potential users. First, research insight. Faster payment and transaction management was validated as an issue, as a pain within the industry. And their first impression was that the blockchain and smart contract can address these industry gaps. Then regarding the dApp potential, smart contracts can boost trust. Stablecoins, which by the way are the proposed means of payment in the dApp, have enormous potential to enable a long desired dream in the construction industry, which is immediate payment. And finally, they also agreed that user-friendly interface are critical for adoption. Challenges and improvements. First, trust in the platform, because they will buy some tokens in advance, the upfront, is to understand the token value and tax implication, which is something that the current framework doesn't cover. And finally, it is also stated that the study limitations, which were the limited blockchain knowledge among participants, of course, because they are construction practitioners. They are not IT guys. Regional bias, as they all were from the same country and the same construction market here in Santiago, in Chile. And finally, as a conclusion slide, I share the recommendation from the study. First, for general research and development of blockchain in the construction, it is necessary to expand stablecoin protocols to private networks such as Hyperledger, and then encourage more practical use cases in real-world scenarios. It's something that it's something that you guys have mentioned before in other presentations. Second, regarding this TAP framework, it is recommended to implement smart contract conditions for token release after the exchange has taken place on the DApp, and both parts are satisfied, of course. Of course, it was also suggested to incorporate digital signatures to streamline document flow in the case of services that can eventually also be offered on the DApp. Then any further study must develop a solution for a stablecoin associated with the DApp. That's something that is completely necessary. And finally, a more objective evaluation is needed in order to analyze scalability, examine latency, evaluate security, and test robustness of the DApp within the Hyperledger to optimize the system architecture. So that's my presentation. Thank you for your attention.